as you settle into the peaceful embrace of your evening rest, feeling the day's energies slowly dissolving like morning mist. Imagine yourself drifting backward through time, not in a rush or with urgency, but with the gentle patience of starlight itself, traveling billions of years into the past to witness the most tender moments of cosmic creation, when the universe first learned how to build the magnificent spiral cities of stars we call galaxies. Tonight, as your breathing finds its natural rhythm and your mind releases the concerns of the day, we're going to explore together one of the most beautiful stories ever told. How the cosmos transformed from a nearly uniform sea of primordial hydrogen and helium into the rich tapestry of galactic architecture that surrounds us today. This isn't a story of violence or catastrophe, but of gentle, gravitational whispers that gradually, patiently, lovingly sculpted the universe into the cosmic home where planets like Earth could eventually bloom with life. Picture the universe as it was roughly 13 billion years ago, just a few 100 million years after the Big Bang. Not as an explosion, but as the gentle expansion of space itself, carrying with it a warm, glowing fog of the simplest elements. This primordial mist was almost perfectly smooth, like cosmic silk stretched across infinity, but not quite perfectly uniform. Embedded within this gentle cosmic ocean were the tiniest of ripples, variations in density so subtle they were less than 1 part in 100,000. Whispers of gravitational potential that would, over millions of years, grow into the grand spiral and elliptical galaxies we see today. These primordial density fluctuations weren't random chaos, but rather the seeds of cosmic order, planted during the universe's first moments, and now ready to begin their patient work of creation. Imagine these regions of slightly higher density as cosmic gathering places, invisible valleys in the gravitational landscape where matter would naturally begin to collect, not through force or violence, but through the same gentle attraction that draws lovers together across a crowded room. As you float in imagination through this ancient cosmic fog, you can witness the beginning of the most patient construction project in the universe. The regions of slightly higher density begin to attract their neighbors through gravity's tender pull. Hydrogen and helium atoms drift toward these gathering points like snowflakes settling into drifts, each particle following the gentle slope of gravitational potential that draws it toward its cosmic community. This process unfolds not in years or centuries, but across millions of years, timescales so vast that human consciousness can barely grasp them, yet somehow perfectly matched to the patience required for cosmic architecture. The universe isn't in a hurry. It has all the time in existence to craft each galaxy with the careful attention of a master sculptor working in 4-dimensional space-time, where the 4th dimension is the slow, steady passage of ages. The first proto-galaxies begin to take shape not as the spiral beauties we know today, but as vast, irregular clouds of gas that span hundreds of thousands of light years. These cosmic nurseries are warm and gentle, heated by the background radiation of the young universe, creating conditions that are neither too hot nor too cold for the delicate work of star formation that will soon begin. Within these gathering clouds, gravity continues its patient work, creating smaller concentrations within the larger ones. The gas doesn't collapse catastrophically, but rather settles gradually, like cream swirling slowly into coffee, creating density gradients that will eventually become the structure we see in modern galaxies. The central bulges, the spiral arms, the outer halos where the oldest stars will eventually reside. The dark matter, that mysterious component that makes up most of the universe's mass, serves as the invisible scaffolding for this cosmic construction. Like the wooden framework hidden inside the walls of a house, dark matter creates the gravitational architecture that guides normal matter into the patterns that will become galactic structure. The dark matter halos form first, creating gravitational wells that serve as cosmic foundations for the visible galaxies that will eventually shine within them. As you rest tonight in the gentle darkness of your room, you can imagine yourself as a witness to this cosmic dawn, watching as the universe's first architectural projects begin to take shape. The proto-galaxies aren't born through violent collapse, but through the gradual triumph of attraction over expansion, as gravity's patient whispers gradually overcome the universe's tendency to spread everything apart. These early galactic nurseries are places of infinite potential, cosmic wombs where the first stars will soon ignite, where the heavy elements necessary for planets and life will be forged, where the great spiral and elliptical cities of stars will slowly organize themselves into the magnificent structures that will light up the cosmic night for billions of years to come. Tonight, as you drift towards sleep, you carry with you the peace of knowing that you are made of atoms, forged in the hearts of stars that were born in these very first galactic nurseries, that your existence is intimately connected to these gentle processes of cosmic creation that began when the universe was young and patient and full of the infinite potential for beauty that we see realized in every galaxy, every star, every planet, every living thing that has ever looked up at the night sky and wondered at the magnificent cosmic architecture that cradles us all in its gentle gravitational embrace. The architecture of attraction, how gravity sculpts cosmic cities. As your body settles deeper into the natural rhythms of rest, let yourself drift further into cosmic time, witnessing how the gentle force of gravity, the same force that keeps you safely anchored to Earth tonight, becomes the universe's master architect, working with infinite patience and artistry to transform those first whispers of cosmic structure into the magnificent galactic cities that will house billions of stars for billions of years. Gravity operates not through force or compulsion, but through the purest form of cosmic attraction, creating curvatures in space-time itself that guide matter along paths of least resistance, like water following the natural contours of a landscape. In the early universe, as the primordial gas clouds continue to grow through gravitational gathering, this fundamental force begins to reveal its true artistry, crafting not just massive accumulations of matter, but elegant, organized structures that follow mathematical principles, as beautiful as any earthly architecture. Picture yourself floating within one of these growing proto-galaxies, surrounded by vast clouds of hydrogen and helium that glow softly with the residual heat of creation. The gas isn't static, but flows in gentle currents, following the gravitational contours created by invisible, dark matter scaffolding. These flows aren't chaotic, but follow predictable patterns, creating spiral streams and rotating systems that will eventually become the foundation for galactic structure. As the proto-galaxy continues to contract under its own gentle gravitational pull, something remarkable begins to happen. Conservation of angular momentum transforms what might have been a simple spherical collapse into something far more beautiful. Just as a figure skater spins faster when pulling in her arms, the contracting gas cloud begins to rotate more rapidly as it shrinks, creating a cosmic whirlpool that will eventually become the characteristic disk shape that defines spiral galaxies like our own Milky Way. This rotation is crucial to the galaxy's architectural plan. Without it, all the matter would simply fall toward the center, creating a dense, spherical blob with little structure or beauty. But with rotation, the centrifugal force created by the spinning motion balances gravity's inward pull, creating a stable disk where matter can settle into organized, long-lasting patterns. It's as if the universe has discovered the secret of creating cosmic cities that are both stable and beautiful, following the same principles that allow hurricanes to maintain their spiral structure and soap films to form perfect spheres. The disk that forms within the dark matter halo becomes a cosmic dance floor where matter organizes itself into increasingly complex patterns. The gas doesn't spread uniformly across this disk, but rather collects into streams and filaments, following the gravitational currents like cosmic rivers, flowing toward optimal locations for star formation. These gas streams will eventually become the spiral arms we see in mature galaxies. Not solid structures, but rather waves of density that propagate through the galactic disk like ripples on a cosmic pond. The mathematics of galactic formation reveals itself to be remarkably similar to the patterns we see in much smaller systems. The way cream swirls in coffee, the way hurricanes organize themselves, the way water drains from a bathtub. The universe, it seems, uses the same fundamental principles of fluid dynamics and gravitational physics across all scales, from the smallest whirlpools to the largest galactic superclusters. As you witness this cosmic choreography unfolding, you can see how different regions of the proto-galaxy will eventually serve different purposes in the mature galactic community. The central regions, where gravity is strongest, will become the galactic bulge, a dense spherical collection of older stars that serves as the galaxy's downtown, bustling with stellar activity and anchored by a supermassive black hole that acts like a cosmic urban center, not destructive but organizing, helping to regulate star formation and maintain galactic structure. The outer regions of the disk, where rotational forces balance gravity more evenly, will become the spiral arms, the galaxy's suburbs, where new stars are born in stellar nurseries, where young, hot blue stars illuminate vast nebulae, where planetary systems, like our own solar system, will eventually form in the quiet spaces between the bright stellar neighborhoods. Beyond the visible disk, the dark matter halo continues to extend far into space, creating a cosmic atmosphere that protects the galaxy from disruption and provides the gravitational foundation that keeps everything in place. This invisible architecture is like the foundation and framework of a cosmic building, essential but hidden, allowing the visible components to shine and dance and evolve without losing their structural integrity. The process of galactic formation isn't uniform across the universe. Different regions, depending on their initial density and the surrounding environment, will produce different types of galaxies. Some will become the grand spiral cities like our Milky Way, with elegant arms and active star formation regions. Others will become elliptical galaxies, more like cosmic suburbs, where star formation happened early and quickly, leaving behind communities of older, redder stars in more spherical arrangements. Still other regions will produce irregular galaxies, cosmic frontier towns, where star formation continues actively, but without the organized structure of spirals or ellipticals. These irregular galaxies often serve as satellites to larger galaxies, creating cosmic metropolitan areas where different galactic communities interact and influence each other's evolution. As the first billion years of cosmic history unfold, the universe transforms from a nearly uniform fog into a rich ecosystem of galactic communities, each one unique yet following the same fundamental principles of gravitational architecture. The cosmic web begins to take shape, a vast network of galactic filaments and voids that resembles the neural networks in a brain, or the cellular structure of living tissue, suggesting deep connections between the organizing principles that operate across all scales of existence. Tonight, as you rest in the gravitational embrace of Earth, you can find peace in knowing that you are part of this vast cosmic architecture, that the same fundamental forces that shaped the first galaxies continue to operate around you, creating not chaos but order, not destruction but creation, not isolation but connection across the infinite reaches of space and time. The first light when galaxies begin to shine. As the peaceful darkness of your evening deepens and your consciousness drifts into the gentle rhythms that precede sleep, imagine yourself witnessing one of the most miraculous moments in cosmic history. The moment when the first stars ignite within those carefully crafted galactic nurseries, transforming vast dark clouds of primordial gas into blazing cities of light that announce to the universe that the age of cosmic illumination has begun. For millions of years, the proto-galaxies have been gathering mass and organizing their structure in patient darkness, visible only through their gravitational effects, like cosmic ghosts shaping the universe through invisible influence. But now, within the densest regions of these galactic clouds, something extraordinary is about to happen. The birth of the first stars, the cosmic lighthouses that will transform the dark age of the universe into the brilliant cosmic garden we inhabit today. Picture yourself floating within one of these stellar nurseries, surrounded by vast clouds of hydrogen and helium that have never known the light of nuclear fire. The temperature here is still warm from the universe's creation, but not nearly hot enough to ignite fusion. That requires a special kind of cosmic midwifery, where gravity compresses gas clouds beyond what seems possible, creating the extreme temperatures and pressures necessary to force hydrogen nuclei to overcome their natural repulsion and fuse into helium, releasing tremendous amounts of energy in the process. The first stellar nurseries aren't like the ones we see today, enriched with heavy elements from previous generations of stars. These primordial star-forming regions contain only the lightest elements, roughly 75% hydrogen and 25% helium, with trace amounts of lithium. This elemental simplicity means that the first stars will be different from any we see in our current universe, larger, hotter, and shorter-lived, burning with an intensity that will illuminate vast regions of space and fundamentally change the chemistry of the universe. As gravity continues its patient work, small fluctuations within the galactic gas clouds begin to collapse under their own weight. These collapsing regions, called protostellar cores, heat up as gravitational potential energy converts to thermal energy, the same principle that makes your hands warm when you rub them together, but operating on a scale involving masses hundreds of times greater than our Sun. The collapse isn't sudden or violent, but follows the gentle mathematics of gravitational dynamics, with the core temperature rising gradually as the density increases. For thousands of years, these protostars exist in a delicate balance, slowly heating up while radiation pressure tries to halt the gravitational collapse. It's a cosmic pregnancy that takes millennia to complete, but eventually, inevitably, the core temperature reaches the critical threshold of about 10 million degrees Celsius, and nuclear fusion begins. The moment of stellar ignition is like cosmic dawn, breaking after the longest night in history. Suddenly, the protostar begins to shine with its own light, not just the warm glow of gravitational compression, but the brilliant radiance of nuclear fusion as hydrogen nuclei combine to form helium and release photons that have been trapped in the stellar core, taking thousands of years to work their way to the surface before finally streaming out into space at the speed of light. These first stars are cosmic giants, some containing hundreds of times the mass of our Sun, burning with such intensity that they shine with the brightness of entire small galaxies. Their surfaces are incredibly hot, perhaps 50,000 degrees Celsius or more, giving them a brilliant blue-white color that bathes their surrounding galactic neighborhoods in light rich with ultraviolet radiation that begins to ionize the remaining hydrogen gas throughout the galaxy. As more and more of these stellar giants ignite throughout the proto-galaxy, the entire structure begins to glow, transforming from an invisible gravitational gathering into a beacon of light visible across cosmic distances. The ultraviolet radiation from these massive stars creates vast ionization regions around them, clearing away the remaining neutral hydrogen and making space transparent for the first time since the universe's earliest moments. The light from these first stars doesn't just illuminate their immediate neighborhoods, but streams out across intergalactic space, beginning to ionize hydrogen throughout the universe, in a process astronomers call cosmic reionization. It's as if the universe is waking up from a long sleep, with galaxies serving as cosmic alarm clocks that announce the beginning of the age of light and structure and complexity. But these stellar giants burn so intensely that they cannot sustain their nuclear fires for long, while stars like our Sun will shine for 10 billion years. These first-generation monsters exhaust their nuclear fuel in just a few million years, a cosmic blink of an eye. Their brief but brilliant lives serve a crucial purpose in cosmic evolution. They are the universe's first nuclear factories, fusing hydrogen and helium into heavier elements like carbon, oxygen, silicon, and iron that will be essential for the formation of planets and life in later cosmic ages. When these stellar giants finally exhaust their fuel, they don't simply fade away, but rather explode as supernovae, not violent destructions, but cosmic gift-giving ceremonies that scatter the heavy elements they've created throughout their galactic neighborhoods. These supernova explosions also create shockwaves that compress surrounding gas clouds, triggering the formation of new stars and beginning the cycle of stellar birth, death, and rebirth that will continue throughout cosmic history. The heavy elements from these first supernovae mix with the remaining hydrogen and helium in the galaxy, creating the first enriched gas clouds that will give birth to second-generation stars. These new stars will be smaller, longer-lived, and surrounded by the raw materials necessary to form rocky planets, complex molecules, and eventually life itself. As you rest tonight, beneath a sky lit by billions of stars, many of them descendants of those first cosmic lighthouses, you can find wonder in knowing that the calcium in your bones, the iron in your blood, and the oxygen you breathe were all forged in the nuclear furnaces of ancient stars that lived and died billions of years ago. Their generous sacrifice making possible the rich chemistry that allows galaxies to evolve from simple hydrogen clouds into the complex cosmic ecosystems that can nurture planets like Earth and living beings like yourself, all connected across space and time by the gentle cycle of stellar birth, life, death, and cosmic renewal. The dance of spiral arms, how galaxies find their rhythm. As your mind continues its gentle drift into the peaceful realm that borders sleep, imagine yourself rising above the plane of a newly formed galaxy, watching from a cosmic vantage point as billions of years of evolution unfold in graceful, slow motion, revealing how these stellar cities develop their most beautiful feature, the elegant spiral arms that transform galaxies from simple rotating disks into some of the most magnificent architectural structures in the universe. From your peaceful observation point high above the galactic disk, you can see that the spiral arms aren't permanent features like the spokes of a wheel, but rather waves of star formation that sweep through the galactic disk like ripples on a cosmic pond, creating patterns of light and darkness that rotate more slowly than the stars themselves, generating the illusion of solid structure while actually representing one of the most dynamic and beautiful phenomena in astrophysics. The mathematics behind spiral arm formation is as elegant as the visual result. As the galaxy rotates, different parts move at different speeds. Stars closer to the galactic center complete their orbits faster than those farther out, just like planets in our solar system. Where Mercury races around the Sun, while distant Neptune plods along at a more leisurely pace. This differential rotation would normally wind up any solid structure like a clock spring, but spiral arms aren't solid. They're waves of enhanced density that propagate through the stellar disk at their own stately pace. Picture these density waves as cosmic traffic jams that move through the galaxy like waves through water. When a star encounters a density wave, it slows down slightly due to the enhanced gravitational field, creating a temporary traffic jam of stars and gas that appears brighter than the surrounding regions. The star doesn't stay in the traffic jam forever. It eventually moves through and continues its orbit. But the traffic jam itself persists, fed by new stars entering from behind. These spiral density waves are triggered and maintained by various cosmic influences. The gravitational pull of neighboring galaxies, resonances with the galaxy's central bar structure, or even the feedback from star formation itself. Like a cosmic orchestra, all these influences work together to create and maintain the spiral pattern that gives galaxies their characteristic beauty and provides the perfect environment for ongoing star formation. The spiral arms serve as stellar nurseries because the density waves compress the interstellar gas as they pass through, creating the conditions necessary for new star formation. It's like cosmic urban planning, where the spiral arms act as downtown districts, where most of the action happens. The bright young stars, the glowing nebulae, the active stellar birth regions that make galaxies so photogenic when we observe them through our telescopes. As you watch this cosmic choreography unfold, you can see how the spiral arms create a natural cycle of stellar generations. The massive, short-lived blue stars that make the spiral arms so prominent burn out quickly and explode as supernovae, enriching the local gas with heavy elements and creating shock waves that trigger the formation of the next generation of stars. Meanwhile, the longer-lived stars like our Sun gradually drift out of their birth spiral arms and into the quieter inter-arm regions, creating the more subdued stellar populations that fill the spaces between the bright spiral features. Our own solar system was born in a spiral arm roughly 4.6 billion years ago, but we've since migrated to a position between spiral arms, in what astronomers call the local arm, or Orion's spur. This migration isn't random wandering, but follows the predictable orbital mechanics of galactic rotation, carrying us through different galactic neighborhoods over hundreds of millions of years. Sometimes closer to spiral arms, where star formation is active. Sometimes farther away, in the quieter inter-arm regions, where cosmic rays are less intense and planetary atmospheres can evolve in relative peace. The spiral arms also create beautiful feedback loops that help regulate star formation throughout the galaxy. When star formation becomes too active in a spiral arm, the energy from massive stars and supernovae creates galactic winds that blow gas out of the star-forming regions, temporarily reducing star formation until the gas can settle back down. This self-regulation helps galaxies maintain steady star formation rates over billions of years, preventing them from using up all their gas too quickly and ensuring that star formation can continue for most of cosmic history. Different galaxies develop different spiral patterns, depending on their mass, rotation rate, and environment. Some galaxies, like our Milky Way, develop elegant two-armed spiral patterns, with clearly defined arms and inter-arm regions. Others develop more complex patterns, with multiple arms, fragmented arms, or ring structures that create equally beautiful but different architectural styles. The most spectacular galaxies are the grand design spirals, where the density waves create nearly perfect logarithmic spiral patterns that extend from the galactic center to the outer edges. These galaxies look like cosmic hurricanes or celestial flowers. Their spiral arms perfectly proportioned according to mathematical relationships that appear throughout nature. From nautilus shells to weather patterns to the arrangement of seeds in sunflowers. As the galaxy ages and evolves, its spiral pattern may change as well. Interactions with neighboring galaxies can disrupt or enhance spiral structure, while the gradual consumption of interstellar gas can cause spiral arms to become less prominent over time. But these changes happen so slowly that they're imperceptible on human timescales. What we see when we look at galaxies represents billions of years of stable spiral evolution. Cosmic architecture that has maintained its basic pattern longer than life has existed on Earth. Tonight, as you rest in your quiet space, you can imagine our solar system's gentle orbit around the Milky Way's center, carrying Earth and all its life through different galactic neighborhoods over geological time, sometimes approaching spiral arms, where the night sky would be ablaze with star formation regions and nebulae, sometimes drifting through quieter inter-arm regions, where the view of external galaxies is clearer and the cosmic radiation environment is more stable. All part of the grand galactic dance that has been carrying us safely through space for billions of years, creating the stable cosmic environment that allows planets like Earth to evolve complex life and conscious beings who can look up at the night sky and appreciate the magnificent spiral architecture that cradles us all in its gentle, rotating embrace. Galactic gardens, how star cities nurture life. As your consciousness settles into the deeper rhythms of approaching sleep, let yourself drift into the heart of a mature galaxy, witnessing how these cosmic cities of stars become something even more remarkable than magnificent architecture. They transform into vast gardens, where the conditions for life can flourish, where the chemical elements necessary for planets and biology are cultivated and distributed with the patience of cosmic gardeners working across billions of years. Imagine yourself floating through the disk of the Milky Way as it existed several billion years ago, when our galaxy had reached what astronomers call chemical maturity, the point where generations of stellar death and rebirth had enriched the interstellar medium with enough heavy elements to support the formation of rocky planets and the complex chemistry that life requires. The galaxy has become not just a collection of stars, but an integrated ecosystem where stellar evolution creates and distributes the raw materials for cosmic complexity. The stellar nurseries within spiral arms continue their work of star formation, but now they're working with enriched material that contains not just primordial hydrogen and helium, but carbon from ancient red giant stars, oxygen from massive supernovae, silicon and iron from stellar cores, and even trace amounts of precious metals like gold and platinum, forged in the most exotic stellar explosions and neutron star mergers. Each new generation of stars inherits a richer chemical legacy than the previous generation, making possible an ever-increasing diversity of planetary types and chemical environments. Within this enriched galactic environment, stellar systems like our own solar system begin to form in the quiet regions between spiral arms, where the gravitational disruption from nearby massive stars is minimized, and planetary systems can evolve in relative stability. The formation of our solar system represents the galaxy's ultimate gardening achievement, a stellar nursery that produces not just another star, but a stable system of rocky and gas giant planets, including one perfect water world positioned at just the right distance to maintain liquid oceans for billions of years. The galaxy's role as cosmic gardener extends beyond simply providing the chemical elements for planet formation. The galactic magnetic field, generated by the rotation of charged particles throughout the galaxy, creates a protective cocoon that helps shield the solar system from the most intense cosmic radiation streaming in from intergalactic space. This galactic magnetic field works in concert with our Sun's magnetic field and Earth's own magnetosphere to create nested layers of protection that make Earth's surface a safe environment for the evolution of complex life. The galaxy also regulates the flow of cosmic materials through gravitational shepherding that operates on vast scales. Comets from the outer solar system carry water and organic compounds that may have been essential for life's development on Earth, while asteroid impacts, carefully modulated by the gravitational influence of giant planets, deliver additional heavy elements and may have helped establish the chemical cycles that sustain life over geological time. As you drift through this cosmic garden, you can observe how the galaxy maintains optimal conditions for life through sophisticated feedback mechanisms. Star formation rates are regulated to prevent the galaxy from becoming too active, which would create dangerous levels of cosmic radiation, or too quiet, which would prevent the ongoing chemical enrichment necessary for planetary evolution. The rate of supernova explosions is carefully balanced, frequent enough to continue enriching the interstellar medium with heavy elements, but not so frequent that they sterilize entire regions of the galaxy with deadly radiation. The galactic rotation itself serves as a cosmic circulation system, mixing materials between different regions and preventing any one area from becoming too depleted in essential elements or too enriched in dangerous heavy isotopes. Over hundreds of millions of years, our solar system's orbit carries us through different galactic environments, sometimes closer to star-forming regions where we receive fresh deliveries of cosmic materials, sometimes farther away in quieter regions where planetary atmospheres can evolve without excessive disturbance. The supermassive black hole at our galaxy's center, rather than being a threat to life, serves as a crucial regulator of galactic evolution. Its gravitational influence helps maintain the galaxy's spiral structure, while its occasional feeding episodes create jets of energy that help regulate star formation throughout the galaxy and prevent the central regions from becoming too densely packed with stars. It's like a cosmic urban planner, helping maintain the optimal balance between stellar density and open space that allows galaxies to remain habitable for billions of years. The galaxy's position within the local cosmic web also contributes to its life-nurturing properties. Our local group of galaxies is located in a relatively quiet region of space, far from the violent galactic collisions and intense radiation environments found in galaxy clusters. This cosmic suburbia provides the stable environment necessary for galaxies to evolve complex structure and maintain steady star formation over the multi-billion-year timescales necessary for biological evolution. Even the galaxy's interactions with its satellite galaxies, the large and small Magellanic Clouds, and the various dwarf galaxies that orbit the Milky Way, contribute to its habitability. These satellite galaxies serve as reservoirs of fresh hydrogen gas that gradually feed into the Milky Way, ensuring that star formation can continue for billions of years into the future. They also help stir the galactic disk through their gravitational influence, preventing stagnation and maintaining the dynamic processes that keep the galaxy chemically active. The timing of our appearance in cosmic history is itself a testament to the galaxy's gardening skills. We live during what astronomers call the stelliferous era, the golden age of galaxy evolution, when star formation rates are optimal. Heavy element abundance has reached levels that support complex chemistry. But stellar lifetimes are still long enough to provide stable energy sources for billions of years of biological evolution. Earlier in cosmic history, the galaxy lacked sufficient heavy elements for Earth-like planets. Later, in cosmic history, star formation rates will decline as the galaxy's gas supply is exhausted. As you rest tonight in your peaceful haven on Earth, you can find deep comfort in knowing that you are cradled not just by your planet's protective atmosphere and magnetic field, not just by our solar system's gravitational stability, but by our entire galaxy's billions of years of patient cosmic gardening, creating and maintaining the precise conditions necessary for worlds like Earth to flourish with life, consciousness, and the capacity for wonder at the magnificent cosmic architecture that nurtures us all within its gentle, spiraling embrace.